Okay, now I am going to take a question. This is a very important question on binary search and a classical interview question. All of you understand array rotation, right? You had a question also in one of your assignments where you were supposed to rotate an array. So you have been given now sorted rotated array. So what do I mean by sorted rotated array? I am trying to tell you the array was initially sorted. Okay, so let's say the array was initially like this: 1 2 3 4 5 6 7. Now it has undergone some units of rotation, some units of right rotation. Okay, so let's say if it has gone 3 units of right rotation, how will it look? If 3 units of right rotation has happened, that means 5 6 7 will come in the beginning and it will look like this. So what you have been given is not this. You have been given this sorted rotated array. You do not know how many units of rotation have happened. You do not know it. There can be n-1 units of rotation, there can be 2 units of rotation, there can be 0 units of rotation also. So you don't know how many units of rotation are there. You simply know the array is of size n and you have been given a key and you have to find the index of the key. Return the index of the key in the array, and if it is not present, then return -1. One more thing that you must assume is that there are just distinct elements. The array just contains distinct elements. A sorted array existed sometime in the history, okay? It contained distinct elements only, just the distinct elements. Now somebody rotated that sorted array, rotated by certain units. You do not know by how many units. So your input is that sorted rotated array. And now you have been given a key and you have to simply find the key in the array. You have to return the index of the key in this array. So let's say if your key was 6. If your key is 6 and this is your input array, what should you be returning? You should be returning index 1 because index 1 is the index of presence of 6. So of course you can do linear search and solve this problem in order n, but think, can you do better than that? If yes, then how can you do? The first thing that I told you, in order for you to apply binary search, it is not necessary that the array should be sorted. There should be certain order, there should be certain ordering, okay? If there is an ordering, by ordering I mean to say that let's say your answer is somewhere, let's say your answer is somewhere that you want to find. Now in the right side of answer there should be some order and in the left side of answer there should be some other order O dash. If this kind of thing is true, then you can always apply binary search, okay? So this is what you should ideally think, that how can I apply binary search and try to solve this problem. So here, what is the concept to solve it? So everyone take a look at board now. Guys, can I say it that whatever will be my input array, it will be made up of 2 individual arrays which are sorted in themselves. Can I say it? This overall array is made up of 2 parts and those 2 parts are sorted individually, isn't it? Let's say if I call this one as part 1 and this one as part 2, part 1 is sorted and part 2 is also sorted. Is that clear to everyone? Everyone agrees to this, right? So now tell me one thing. If let's say the entire array was sorted, you would have solved the problem very easily. But now you know that it is sorted in parts. There is one part here and there is another part over here. So if somehow you are able to detect the breakpoint, then will you be able to solve the problem very easily? If you are able to detect this breakpoint, then you can do it very easily, right? Because if you are able to detect this breakpoint, then you have one sorted array and then you have another sorted array. So you can first binary search in this, and then if you did not get here, then you can binary search in this. Is it clear to everyone what I'm trying to say? Yeah. So now the entire problem reduces to the problem of finding this breakpoint. How many of you can find this breakpoint? AI smaller than AI minus 1. That is right. But can you do it using binary search? Can you figure this point out using binary search? The answer is yes. So I had told you that if there is an order in this part which is different from the order in this part, then you can always use binary search and solve the problem. Now let's see how I can do that. So you have 5, 6, 7 with you, and you have 1, 2, 3, 4 with you. Guys, if let's say this is my part 1 and this is my part 2. Okay, let's say this is my last element of the array, which is a of n minus 1. Guys, tell me one thing. Can I say that every element in the first part will be strictly greater than a of n minus 1? Can I say it? Yes, no, right? And can I say that every element in second part will be smaller than or equal to a n minus 1? Can I say it? Yes, no? Clear? Right? But tell me, would I have been able to say this thing so easily if the elements were not distinct? If the elements were not distinct, then would I have been able to say it? No. Why no? Because what if this had repetitions? If this had repetitions, then you could have had 1, 2, 3, 4, 4, 4, 4, 5. Now, here also for an element, you have lesser than equals to 4, and here also for this element, you have lesser than equals to 4. So, this is not going to work. That is the reason elements that have been given are distinct. Is everyone able to understand the significance of distinct elements? Because the reason elements are distinct, you are able to figure out which part has which kind of property. Okay. Now, if you know this property, then you can solve the problem very easily, isn't it? How you can solve the problem very easily? Let's say you are applying binary search and you are at a particular mid. Okay. If you see that a of mid is smaller than equals to a of n minus 1, what does it mean? If a of mid is smaller than equals to a of n minus 1, does it mean I am in the right side of answer, which is the right side of my point that I am trying to find? I am trying to find that 7, right? You are trying to find the index of this 7, because if you find the index of this 7, if that index is I, then you have a portion 0 to I and you have a portion from I plus 1 to n minus 1, which are sorted in themselves. So this I is to be found. So if you see that a of m is smaller than equals to a of n minus 1, that means you are in the right side of your answer. If you are in the right side of your answer, that means you should move left. Now what should you do to move left? How do you move left? To move left, can you simply do high equals to m minus 1? Yes, no, that was what we were all doing, right? So whenever you are in the right side, guys, see, the entire point is of detecting whether you are in part 1 or whether you are in part 2. Can you utilize this property that I just spoke to figure that out? You can utilize this, right? Just you have to compare am with an minus 1, which is the last element. So if am is smaller than equals to an minus 1, that means you will do high equals to m minus 1. But if let's say the condition is opposite, if am is greater than an minus 1, what does it mean? Does it mean you are in the first part? It means you are in the first part, right? But now there can be two cases. What two cases can be there? Either you are at the answer or you are at before the answer. So can you detect whether you are at the answer or before the answer? Can you detect it? I believe it should be very easy, right? Because if you are at the answer, can I say that a of m will be greater than a of m plus 1? Can I say that this relation is true only for this value of m and not for any other value of m? Yes, no? So if you are in the part 1, that is, if this condition is true, then you first check this thing. So if this thing is true, if a of m is greater than a of m plus 1, that means, hey, you got your breakpoint. So you just return it. You return this breakpoint. Okay? Otherwise, that means you are in the left hand side of your answer here, or here. So in this case you should move to the right side. How do you move to the right side? To move to the right side you will do low equals to m plus 1. Is it clear? How many of you are clear with this? Can everyone implement it? So guys, here also I searched an element. Okay. To search that element, I did not require the array to be sorted. I just required some property, some order, and that was this property. So in the right side of my answer, there is a different property, and in the left side, there is a different property. Making use of this fact, I have been able to perform the search. So does this example convince you of the fact that to perform binary search, sorting is not the only order? There can be many different kinds of ordering, like one that you saw over here. Is that clear to everyone? Are you able to understand this thing? Yes or no? Right? So this is a very important point that I want you all to realize. Okay? So you just have to look out for a property which is different in the right and left half of answer so that you can apply binary search easily. Okay? So this is how you can get this thing. Now, what will be the time complexity of this approach? It will just be log of n, simply log of n, because here the first step was to detect this element, okay, breakpoint. To detect this element, the logic that you have, it always does order one work in its specific iteration, and then it halves your search space. So it will take log of n base 2. And once you have detected this part, then you can simply do binary search in this, which will take log of I base 2 time, and then binary search in this, which will take log of n minus I base 2 time. And if you sum them up, this is like order of log n base 2. Okay. So once you have figured out that breakpoint, then you just have to perform binary search in the two halves. Tell me one more thing. Is it necessary to do binary search in both the halves, or can I figure out where I have to do the binary search? Can I figure out? I can figure that out very easily. Because if, let's say, the key that I have, the key that is to be searched, if that key is greater than the last element, that means I should search in this half. But if that key is smaller than or equal to the last element, then I should search in the second half. Is that clear to everyone? Did all get it? Right? Yeah. So I think if you have to write the code of this. Okay. So to start with, you will initialize your low and high variables. So your low will be 0, your high will be n minus 1, and your condition will be while low lesser than equals to high. So guys, the logic that I am writing right now is to simply determine this breakpoint, because once breakpoint is determined, then you know what to do, right? So first I'll find my mid, which is low plus high by 2, and then I'll check if my a of mid is smaller than equals to a of n minus 1. Yeah, can somebody tell me what should I write here? If a of mid is smaller than equals to a of n minus 1, if my current element is smaller than or equals to the last element, which part you are in? Are you in first part or second part? You are in the second part. So your answer lies to the left. So what will you do? You will move to the left. To move to the left, you will do high equals to mid minus 1. Everyone is clear with this, right? Okay. In the else case, whenever you are in the else case, what does it mean? You are in the part 1. Now when you are in the part 1, how many cases can occur? 2 cases. Either you are already at the answer or you are before the answer. So how do you detect if you are already at the answer or not? If you are already at the answer, then you will see this property that am is greater than am plus 1. So if you happen to see that am greater than am plus 1, then you simply need to return m. And in this way you will get this index. Okay. Otherwise, it means that you are towards the left side of your answer. Since you are at the left side of your answer, you need to move to right. To move to right, you need to do low equals to m plus 1. Okay. Is it clear to everyone? Did everyone understand it? Guys, tell me one thing. Do I have to be careful in this code at certain point of time? Can I end up getting index out of bound exception in this code somewhere? Can this particular thing lead to index out of bound? How many of you feel it can lead to index out of bound? In case of zero rotation. So somebody is saying that in case of zero rotation, it can lead to index out of bound. Really? Will it really lead to index out of bound? Let us take a case like this, 1, 2, 3, 4. Is this a case of zero rotation? Is this a case of zero rotation? Yes, no. This is a case of zero rotation, right? So to start with, you will have your low and high over here, okay? You will have your low and high over here. So can I say that if you apply this logic, your low will remain fixed, just your high will keep on changing? Isn't it? Yes, no, just take a look and tell me. Because whatever mid you will get, you will see that A of mid will be smaller than equals to A of n minus 1. So this will change and come over here, okay? Then again, you will find that the mid is here, so now your high will come over here. And this is how you will basically terminate. So basically, if there is no rotation at all, in that case there is no break point. So you will terminate. Is that clear to everyone? So you will simply terminate, but that error will not happen. It will never ever happen that A of m greater than A of m plus 1 check has happened for the last index, because the last index can never be a peak kind of thing, okay? Even if there is, let's say, just one rotation, if the case is like this, then this will be your m and this will be your m plus 1, which again is safe. If there are two rotations, you will have like 1, 2, 3, 4, 5. Okay, if this is your m, this is m plus 1, again safe. If there are 3 units rotation, 1, 2, 3, 4, 5, again safe. Okay, if there are 4 units of rotation, 1, 2, 3, 4, 5, again safe. If there are 5 units of rotation, then that is back to something like this. So the loop will break. You will never ever get the index out of bound exception. How many of you understood it? Just say yes. Is that clear to everyone? So in this kind of case, you will never ever encounter that kind of case where index out of bound exception can happen. Okay, so I think it's easy. One thing that you can do is you can always first check whether the entire array is sorted or not. Can you just check whether the input array has zero rotations or not? Can I simply compare the first element and last element to do that? If the first element is smaller than the last element, can I say that, hey, the entire array is sorted? Yes, no. I can say that, right? So in that case, I will simply do binary search on the entire array. And if that is not the case, then I will run this logic of finding m, which is the breakpoint, and then apply the binary search in required half. Okay? You just have to be aware about certain cases. If the size of array is 1, if there is just one element in the array, then I think this is nonsense. You need to take care of it additionally. I mean, just compare this one element. And if the array is empty, take care of that corner case also.